Today we're going to be looking at the density equation and manipulating the variables associated with the density equation to solve for various pieces. We're also going to convert between Celsius and Kelvin temperature scales. Okay guys, so density is an intrinsic property, meaning that a specific substance is going to have a density regardless of the quantity of that substance that is present. Okay, so a thimble full of water is going to have the same density as a swimming pool full of water. Okay, so if we're just talking about pure water, the density is going to be consistent. Now, density is going to be related to the mass and volume of that specific object. Okay, so density, as we see here, okay, is equal to mass over volume. Okay, and our mass, guys, is typically given in grams or kilograms, although grams is most common. And our volume is typically going to be in centimeters cubed or milliliters, and even sometimes liters. Okay, so the most common units, though, that you're going to see is grams per milliliter or grams per centimeter cubed as your volumetric measurement. Now, I do want to mention, guys, that 1 milliliter is going to be equal to 1 centimeter cubed. So this relationship here is going to allow you to do interconversions when necessary. So this problem here has indicated that we have been provided the volume of our object as well as its density, and they want us to find the mass. Okay, so first thing we do on our problems is we write out our variables. 825 centimeters cubed for our volume, and then our density here is going to be 13.6 grams per centimeter cubed. Okay, and we have these variables. Now they want us to find mass, so what we'll then do is we will take our equation that we know and we'll manipulate it for the appropriate variables. Okay, so mass is going to equal density times volume. Okay, and we need to make sure that we're writing out our variables, that we're manipulating our equation before we plug in our numbers. And then what we do is we check and make sure that our units will work out. Okay, so notice my volume is in centimeters cubed. The volume component of my density variable is also going to have the cubic measurement there. So that matches up. And of course, grams is a mass unit, so it makes sense that we'll end up with the units we're supposed to have. So if we take our variables and we plug them in with our actual values, we're going to get 13.6 grams per centimeter cubed times our volume, which is 825 centimeters cubed. Okay, and we're going to go ahead and multiply that out. That's going to give us the following. Okay, and so if we go ahead and we look at our units, centimeters cubed and centimeters cubed cancel, grams are left over. And then if we consider significant figures, I have 3 sig figs here, 3 sig figs here, so my answer needs to be recorded to 3 sig figs. So this is going to give me the following final answer. Okay, so that's going to be our calculation of mass using our density equation. So here we have another practice problem. In this case, they've given us a mass that's equal to 225 grams, and they've given us a density equal to 444.1 grams per centimeter cubed. And they want us to find our volume in milliliters. Okay, so again, we take our equation for density, and we need to solve for V. Okay, so volume is going to equal mass divided by density. Okay, now we check our units. We got grams and grams. Those would end up canceling. And we have centimeters cubed, so we plug that in. Okay, so 225 grams divided by 444.1 grams per centimeter cubed. Okay, that's going to give us 0.506642. Okay, if we go ahead and we look at our units, remember that dividing by a number is the same as multiplying by a reciprocal. Same thing is true for units. So if I have grams on top and grams per centimeter on the bottom, that would be the same thing as saying grams times centimeters cubed over grams, right? Multiplying by the reciprocal is the same as dividing. Grams and grams cancel, so centimeters cubed is what I end up with here. Okay, significant figure-wise, 3 sig figs, 4 sig figs. Okay, so we got our 3 sig figs there, so 0.507 centimeters cubed is what we have. Now, remember, you need to go back and check what they're asking for. So the unit that they're asking us to obtain is milliliters. Okay, so centimeters cubed is not a milliliter, obviously, but we do know a conversion factor between our centimeters cubed and our milliliters. We know that 1 milliliter equals 1 centimeter cubed. Okay, so since we know that conversion factor, we're going to go ahead and use that relationship. 1 milliliter, 1 centimeter cubed. Okay, and that's going to give us 0.507 milliliters as the volume of our object. Okay, so this is solving volume using the density equation when you're provided with grams and density. So now we're going to go ahead and we're going to talk about temperature conversions. Okay, so honestly, guys, this is what we're typically dealing with when we're talking about, what's the temperature outside. Why? Because we use Fahrenheit in the United States, while most of the world is going to be using Celsius to describe the temperatures outside or during cooking, what have you. So what we're going to be doing is we're going to be focusing on Celsius temperature and Kelvin temperature conversions. Both of these are commonly used in scientific analysis of chemical reactions and what have you. And so basically we are going to get familiar with these conversion factors. Now, Fahrenheit is not something I'm going to be asking you about in this class, but if I did for some reason, I would provide you with the important equation needed. Okay, so if we go ahead and we look at our first equation here, Kelvin, our temperature in Kelvin, is going to be equal to our degrees Celsius plus 273.15. Okay, so if we take our temperature in Celsius, we take our conversion factor and add it to our temperature in Celsius, we'll end up with Kelvin. Okay, and then if we manipulate this same equation and solve for just Celsius, what you'll end up with is Kelvin temperature minus 273, okay, 0.15. So these conversion factors are pretty straightforward. It's really, really basic math. So let's go ahead and practice. All right, so they want us to convert 22.2 degrees C to Kelvin. Okay, so we have 22.2 degrees C. So that's our temperature in Celsius, and they want Kelvin. So Kelvin is going to equal degrees C plus 273.15, right? Okay, so if we plug that in, Kelvin's going to equal 22.2 degrees C plus 273.15. We add those two together, and that's going to give us 295.35 Kelvin as our temperature. And we're adding here, so places to the right of the decimal. Least places to the right of the decimal is 1. So 295.4 Kelvin is what would be our final answer here. So in that same vein, if we were provided Kelvin and converting back to Celsius, we'd be subtracting out the 273.15 from our Kelvin temperature. Okay, so listen, guys, you're not going to be provided with these equations. You need to be able to manipulate them. You need to know how to use them appropriately. And basically, that's what's going to be provided or expected on the exams.